All right, stats here. 2, 4, calculating the correlation. Again, goes along with 2, 3, where we talked, what correlation was. Um, first of all, how do we calculate it? Well, if your x is your explanatory and your y is your response, there's this very, very, very confusing looking formula right here. Again, we are not going to use this. But a couple of things I wanted to point out. We're going to learn 3 properties of the correlation, and I want to focus your attention on these z's here. So if you remember from chapter 1, section 1, section 9, 1 9, z score or standardized score. So because we are using this formula right here, this is turning our variables into standardized scores, which means they become unitless or have no units. Okay. In addition, we could interchange the x and y. Okay. So be aware that it's just multiplication. You can do it either way. So keep that in mind as we look forward to, I think, objective 2 about the 3 properties of correlation. The last thing to note right here is that if you're going to calculate correlation, both variables must be quantitative, right? You're using this formula, you have to have numbers to plug into the formula. So again, if you're doing categories, there won't be numbers to plug in. So be aware of that. That correlation has to do with quantitative variables. All right, so example 1, what's the correlation between foot length and height? The table shows the foot length in centimeters and height in centimeters for a random sample of 6 high school seniors. Calculate the correlation for these data. All right, so first off, I want to try to talk about which I think is the X or the explanatory and which is the Y or the response. And to be honest, when you have these two measurements, foot length and height, it doesn't matter. So either one could be the explanatory or the response. So what this means, that either one could be, it's unclear which one should be which, right? One doesn't predict the other. So let's let foot length be the explanatory. That means that foot length is going to be our X, and let's let height be our response, and that means it's our Y. Okay, that's response Y. And again, understand that foot length has 2 columns. See, these are more X's and these are more Y's. So I will take a picture of this table, and we're going to go ahead and input it into our 2 quantitative stats applet. All right, so let me erase this real fast. Okay, let me get out of here. Let's go to our stats applets. Again, this is our 2 quantitative stats applet. Stats applets, 2 quantitative. Again, I don't care about, okay, so we'll put foot length. It doesn't really matter because I'm not making you graph this in a scatter plot. If I was, you would have to pay attention to these names of these variables, but I don't care. And again, we're just going to go order. First column, 23, 32, 22. And then the second foot length column is 28, 28, and 23. Okay, now we have the height. And again, go back in the same order, 167, 188, 150, 163. I'm in the second height column, 185, and 155. Okay, so I went in order. I'm going to begin analysis. Okay, so there's my scatter plot. And down here it says calculate correlation. Please do that. And there you go. There is your correlation value. R equals 0.841. A relatively strong positive linear correlation or association, 0.841. So I'll go back here and we'll go ahead and write that down. Your R value is 0.841. And there we go. That's objective 1. Objective 2 is coming.